Okay, so again, here's an equation identical to the other one, except I slipped an e to the negative 0.07t in here. To solve it, we follow the same first two steps. We multiply through by the denominator and we get this, and that's very easy to see and verify, and then we use the distributive law. Boom, boom, two easy steps that everybody, I'm sure, would do correctly. Now, what do we do after this? Anybody that wasn't in the MCR want to tell me what we can do next?
I want to say combine like terms, but I know it would be not right.
I'm sorry, Miles?
Combining the like terms.
Combining the like terms, exactly. What are your like terms?
Let's say 80e to the negative 0.07t, and then the one that corresponds with the other side.
Yeah, exactly. Okay, that is exactly what we do. We have like terms here and here, right? Mm-hmm. And if we subtract this one from both sides, then those like terms are going to be in the same side, and we can combine them, right? So that's all we do. Excellent. Okay, so we subtract that, right? And we end up with 0 on this side. That won't stay 0, but right now it's 0. Equals 50 plus, well, we're going to have the 100 e to the negative 0.07t minus 80 e to the negative 0.07t. Those are like terms, so we can say, well, that's going to give us 20 e to the negative 0.07t, right? Now, in terms of the fundamental laws, because there's no fundamental law about like terms, it's just the distributive law. This minus this is 100 minus 80 multiplied by e to the negative 0.07t, right? So that's factoring, which is just using the distributive law backwards, okay? So that's the justification, and that's a whole justification for adding or subtracting like terms. And I'm sure nobody ever told you that. So if you lock that idea in, okay, but if you see these as like terms and do this, I'm happy. Okay? Very good. Excellent. Okay, so now we subtract 50 from both sides, right? And we're at the stage where we have e to the negative 0.07t. Well, we have 20 e to the negative 0.07t equals negative 50. And then we divide by the 20 and we get this, and that's all very straightforward. Okay? Now, the 50 divided by 20 is 2.5, and of course it's going to be a negative 2.5, so this leads us immediately to e to the negative 0.07t equals negative 2.5, right? How do you solve that? One way to solve it, without going through anything else, is to say e's a positive number. You raise a positive number to any power, you're going to get a positive result. And this is negative, so there's no solution. This equation has no solution. There's no t, no value of t that gives you a solution here, that makes this equation true. Okay? Now, likely, in the heat of the battle, you're going to not notice that. Okay? And that's okay. You're going to have to do a little extra work, but you're still going to come to the same conclusion. Because by the time you get to your calculator is going to yell at you and say there's an error. Then maybe you go back and think about why. Okay? So, we change this to logarithmic form. It's log base e, so that's natural log. So t is the natural log of negative 2.5 over negative 0.07, right? Now I guarantee you, if you put natural log of negative 2.5 into your calculator, it's going to say error or something equivalent. Now, if it's one of those calculators with an attitude, maybe the lithium battery will blow up in your face.
Ooh.
I hope not.
Wait, what? Are we, why?
Okay?
Why are we hurting each other?
No, that's not going to happen. At least that it might happen if you got a lithium battery and abuse it, but not as a result of asking it to do this calculation. It's very easy for the calculator to say, well, that's outside the domain of the function. It's an error. Okay? Now, you then ask yourself, why did I get an error here? Well, there are many explanations. One is you go back to this step and you realize the exponential can't be negative, right? Well, another thing you can do is you can graph the natural log function. Graph looks like this, doesn't it? You're trying to do the natural log of negative 2.5. Where's negative 2.5? It's over here. Where is the value of the natural log that corresponds to x equals negative 2.5?
There is not one.
It's got to be on this vertical line, and this graph doesn't come over there, right? The graph is asymptotic to the negative y-axis for reasons that you should understand, because you understand the exponential function and understand this is just what you get when you reverse coordinates to get the inverse function, okay? And that gives you a much better picture of these functions and what everything means. And we're really trying to tie in these last 2 weeks, we're really trying to tie these pictures together, okay? So think about that as we look at some other examples.